Hey folks, welcome back to Icon Designs. I'm your host Mark, and today in my shop we're going to be taking this beautiful walnut slab, using my CNC and creating what I'm calling a smart end table. I'm calling it a smart end table because it's got a hidden trick up its sleeve. Not only does it look really cool and unique, but it's actually got an embedded phone charger on the underside of the table. Now you can't see it from the top, but when you move your phone in the right position, it starts to charge your phone. So if you want to see how I built this, then stick around and I'll show you how. About 5 months ago, I bought this walnut slab from a local dealer, not having a specific project in mind for what I wanted to do with it, but it had some unique characteristics and I thought it was really well priced, so I went ahead and bought it. And for those who have been watching my channel for the last couple of months, you probably saw this make some cameo appearances in the back of my shop. It's just been lurking around waiting for me to put it to good use. Well, today is the day that we're going to do that. So to start off this project, I used a straight edge in my circular saw to cut off the piece that I want to use from this particular slab. You'll notice here that I make 2 passes because I found that the cut quality is substantially better if you try not to do it all in one pass. Once I've got that piece cut off, I then repeat the process, but this time I cut it right down the middle so that we can turn both ends towards itself and have the live edge in the middle of the board. Once that's done, I then go over to my jointer to put a straight edge on both of the pieces that we just cut. With that done, I head over to my crosscut sled to put a nice fresh edge on both of the pieces, and you should end up with 2 mating pairs that look like this. With these pieces cut to a smaller size, I now take the opportunity to run both of these through the planer so that we start out with 2 even thickness boards, which will be really important for the next step whenever we start doing the CNC inlay work. I've been doing a lot of CNC inlay work and really experimenting with what the limitations are. And I found that a program called Easel does this really well. You map out what you want to do in the software, and then there's an application within Easel that automatically creates the pockets and the inserts for whatever it is that you're going to be creating. So I'm going to be using this instead of Fusion 360 for that reason, but most CNC softwares are capable of doing this if you know how to do it right. One other thing I want to highlight here on the CNC work is I'm going to be taking off my dust boot because of the location of some of my clamps. Whenever this is done cutting, it's going to return to a home position, and those clamps can get the dust boot stuck on them and cause some problems, so I'm going to remove that. While this is cutting, I just want to mention that if you don't have a CNC, you can do this by hand with a normal router and a chisel. I am a one-man operation, so I think of the projects myself, I gather the materials, I build it, and then I also do all the filming and video editing on my own. And one of the reasons I got the CNC was to enable me to do stuff beyond my own capabilities. So if I can design something in a CNC software in 10 or 15 minutes and let it run, instead of spending 10 hours cutting it myself, that saves me a lot of time and also extends my capacity to do work in the shop. So that's kind of the direction that I'm taking my channel, using my CNC as a enabler to get more work done. But that doesn't mean that folks that don't have a CNC can't find other ways to get this done using more traditional methods. So with that being said, once I had my pockets cut out and my inserts cut out, I used a little bit of wood glue to secure those in place, and I tapped them down with a rubber mallet. It is a pretty tight fit, and I also used some parallel clamps just to make sure that there was good lateral pressure coming from the sides as well. Once the inserts have a chance to dry, I then put the tabletop back into the CNC to flatten it. I do this using a 1-inch surfacing bit, which makes pretty quick work of this. Since we're going to be boring out a lot of material in the next step, starting out with a flat and parallel surface is really important. In the wireless charging testing that I did, 1/8 of an inch was about as thick as you could have a material before the signal gets lost. So I use that as a reference point to start my machining, and we're going to be boring a hole all the way through the board, leaving only 1/8 of an inch of material on the surface. So accuracy here is really important, and as soon as this was done cutting, I had to take it out of the CNC and go test it because I was really curious if it was going to work. So I plugged in the wireless charger, put my phone on top, and it worked. So on to the next step. I'll be making a shelf that's going to sit on the lower bracket of the metal legs using some 4/4 inch rough sawn walnut. I begin by rough cutting 3 pieces to about 23.5 inches, which is about 1 inch longer than their final dimension. Once I've got these 3 pieces cut, I can then go through the jointing and the planing process and begin fabricating what's going to become the bottom shelf. If you don't have a joiner or a planer, you can skip this process by buying S4S 3/4 inch lumber that's already been milled. After joining the boards, I make some light pencil marks on the surface that's yet to be run through the planer so that I know when all the boards have had all the pencil marks removed. That'll be an indication for me when I can stop planing these boards. Once that's done, I then go over to my table saw and rip the remaining rough edge off of each of the 3 boards, so I've got 3 boards that are now S4S. I'll be using some black powder coated metal legs that I found on Amazon, and I'll leave a link to those in the description below, and I'll be attaching them to the tabletop using some threaded inserts. I start off by using a Phillips head screwdriver as a hole punch, where I'll later come through and drill the pilot holes and then install the threaded inserts. This allows you to secure the legs using a machine screw rather than a wood screw. So not only is it better, but it's a very inexpensive way to up the craftsmanship of your projects, and I'd highly recommend it. After that, I temporarily install the legs so that I can start to notch out the shelving that's going to be in the bottom part of this table. I transfer the markings onto the wood using a square. Then I head over to my table saw and use my crosscut sled to cut out those notches. I set the height of my blade to 1 inch so that the notches are exactly 1 inch high. With all the notches cut, I do a quick dry fit and measure the gap in between those 2 boards, which is about 3 inches, and then I rip that last remaining piece on my table saw so that I can then have one continuous piece for this lower shelving. While I have everything aligned perfectly, I use my pencil to make a few marks across the different boards so that I can replicate this in the glue up that's to come. For this glue up, I use my Bessie parallel wood clamps as well as some Titebond 2 to make quick work of this. Once the bottom shelf has a chance to dry, I run it through the planer on both sides just to get rid of any uneven surfaces and remove any excess glue that's remaining. I then make one final trip back to my crosscut sled to put a nice fresh edge on both sides of this shelf and also to cut it to final dimension. To begin the sanding work, I head over to my downdraft table, which is actually embedded into my workbench itself. This really helps cut down on any stray dust that I produce while I'm sanding. For the grit progression on this particular project, I'm going to start out with 80 grit, then move my way to 120, then 180, and then 220. This is a pretty standard progression, and I apply it to both the tabletop and the shelf that we just finished building. While my downdraft table is still running, I take the opportunity to put an 1/8 inch roundover on all the exterior corners of both the shelving unit and the tabletop itself. I've gravitated towards the 1/8 inch roundover over the 1/4 inch roundover with time because it's a very subtle way to soften the edges and still retain a very attractive and elegant look. I would normally finish a wood project like this with some sort of a wax oil finish like Rubio Monocoat, but given the intricacies and the tight spaces of the inlay work that we've done on this board, I'm going to use something aerosol based, and I elected to go with a semi-gloss lacquer. This is really easy to apply. It's just sprayed on and it dries very quickly, so you can build up layers without having to wait hours in between coats, and it goes on really quickly. The final step in this process is to install the wireless charger. And I do this by using a hot glue gun to put glue in 3 different places, almost like a hot glue gun tack weld. That way I can remove it if I ever need to. So this is how the final smart end table turned out. I really like the look. I think the maple cross stitching that holds the 2 different live edge pieces together is a very unique look. And the charging capabilities is something that you just don't see, and I feel like this is something that's ripe for mainstream once furniture manufacturers catch on to this. Now, I did this as a proof of concept because as I build more tables and other large-scale furniture, I think this would be a really cool feature to include. I wanted to try it out on a small scale before trying it on something large and really expensive. I'd say total build time for this project was about maybe 10 hours total from start to finish, and using the CNC really allowed me to make this a quicker project than it would have taken me by hand. So thank you very much for watching this video. Smash that like button, subscribe if you want to see more content like this, and I will see you on the next one.